Okay, I think for number 6 I made an error, but I'll go through it at the whiteboard. And as I go through the whiteboard, I want to point out why I think it's an error. It's because of this over here. And that's not true. I'm not sure. A lot of times when I write up a key, um, maybe I was thinking of something else. I don't know. But it does happen sometimes. But that's certainly not true. Um, so I'm going to go to the whiteboard and do it. I also want to point out Wells. Um, he provides no work for this problem, nor does he provide any answer for this problem. And this is typical of his book. He really very sparse in what he provides. But again, my suspicion that Wells, um, did the problem and he wrote an answer down. But this is not the correct answer written down, just looking at it. So I'm gonna go to the whiteboard. As I go to the whiteboard, I'll go through the steps that we'd want you to go through yourself. And let me just pull the whiteboard up. Let me expand it out, get my pen out, and start writing. So the first thing is just a factor, and it's not a bad factorization. I mean, the first two are really kind of simple. And that's a cube, right? And that's a difference of perfect cubes. So that's 2m minus n. Relatively simple. 4m squared plus 2mn plus n squared. Relatively simple. The next one's also relatively simple. It's 4m squared minus 4mn plus n squared. And this factors to 2m minus n quantity squared. You get 4m squared minus 4mn in the middle and plus n squared in the end. The last one, though, is I call a more difficult one. And I did really, it's sort of unproductive too, but let me go through it. And this is the most difficult one there. I can understand looking at it and saying, gee, I don't even know where to go with that. However, we have seen them before. So I'm gonna try to do it. So 16 m4. I'm gonna try to make it a perfect square. So I'm gonna say plus 8m squared n squared plus n4, and then I have to take away minus 4. So I hope you realize that what I'm saying over here, I'm saying this here is identical to this over here. All right, you should take a moment to look at that and either agree with that or say, what happened. Well, all I did was I said 8m squared n squared minus 4m squared n squared is equal to 4m squared n squared. Now, the big question is, why did I do that? I did that so I could see a perfect square here and a perfect square here. That's why I did it. So let's write down what the perfect square is. It's going to be 4m squared plus n squared squared. Let's just go through that. I get 16m4, and then you get, 4 and 4 is 8, m squared, n squared, and then you get n4. And over here, this is also a perfect square. What is it going to be? 2mn squared. Now, why did I do that? So I could factor it, right? That's my whole point. I want to factor it, all right? Now, by the way, someone could be rather flippant and say, oh, just put parentheses on it and it's factored. I wouldn't disagree with that. That's factored now. But here's the deal. Let's see what happens when I do that. You get 4m squared plus n squared minus 2mn, and you're going to get 4m squared plus n squared plus 2mn. All right? Now, what I notice kind of remarkable about this, I notice that they have some factors in common. So, for example, this, same factor as this guy over here. Unfortunately, this guy over here, I'll point it out to you. I mean, you can try to factor that guy, but you're just not going to go anywhere with it. And what I mean by that, you might want to do the same thing we just did, which is 4m squared, and then, add something in the middle. What would it be? It would be 4mn plus n squared minus 6mn. And I'm not opposed to it. I mean, you could do that. It just doesn't seem to be going anywhere productive. Again, this is 2mn plus n squared. And what do you get over here? Well, you get 2m plus n quantity squared minus 6mn. And that's where I'd get into like writing down roots and stuff. So it seems unproductive, right? So I'm gonna erase that. It's unproductive behavior. And what I want to do now is I want to talk about the LCM of those three guys. Right, I'll pull this over here. So the LCM, and this is where I made an error in my K. Well, it's going to be 2m minus n squared. I'm seeing that here. Those factors are shared. And the maximum numbers occurs in any one factorization is once. I see this. That occurs at most once. And I see this. But I got to be honest with you. It almost seems pointless. And I'll tell you why. If you multiply this out, what would you get? You'd get this back. So the LCM is just simply 2m minus n squared, and then I'd get 16m4 plus 4m squared n squared plus n4. This is probably the neatest version of the LCM. However, I can understand someone writing this one down as well. All right? That's it. End of the story. Thank you.